Naturalness of software? Isn't software supposed to be artificial? Well, let us explain. Consider natural languages like English, German, or French. These languages have very rich vocabularies and a tremendous variety of grammatical and idiomatic constructions. Using these languages, capable writers like Goethe or Shakespeare or Moliere can come up with tremendously intricate and beautiful works of literature. However, if you look at what most people write and say every day, it's pretty simple, repetitive, and maybe even a little boring. This simple, repetitive nature of natural utterances, everyday utterances, can be captured in statistical models and used to great advantage in tasks like natural language translation and speech recognition. If you use Google Translate or Siri on your iPhone, you know exactly what I'm talking about. So now we make a rather audacious, analogous claim about software. Although programming languages per se are tremendously expressive and allow a great variety of complex and intricate programs to be written, we claim that most programs that people write are pretty simple, repetitive, and even a little bit boring. And we claim that this repetitive, simple nature of natural programs can be captured in statistical models and exploited. So let me give you a little teaser on what this means. Consider English. The average word of English has only about 6 or 7 bits of information. Despite the tremendous vocabulary and grammatical and idiomatic complexity, each English word has only a small amount of information. In other words, it's not that surprising. It is this property of English that allows us to recognize speech in the presence of noise and translate between English and other languages. Now, turning to code, what we have found is that code only has about 2.5 to 3 bits of information per token. So in other words, code is about 8 times as predictable as English. Code is much more repetitive, much more regular, maybe much more boring. Okay, so what can we do with this? We believe that we can estimate statistical models over large code corpuses and use them for a variety of different applications. For example, helping programmers by guessing the next token, helping programmers with disabilities to input programs using speech, programming with limited devices that maybe only allow gestures, translating between code and English in certain limited settings, for example, for code summarization or code retrieval given an English description. Maybe doing quick, superficial, good guess static analysis that is correct most of the time, again using statistical models over large code corpuses. And finally, using models of code to synthesize sample bits of code that can be used in search-based methods. We've already built code completion engines and demonstrated that statistical models provide significant advantages over the best available code completion engines. So come to a talk and hear all about the naturalness of software. You will be surprised.